Hi there, this is Jacob Nash Algebra Lessons, and this is Unit 6, Lesson 5, on basically just knowing perfect radicals. So if you're wondering why the intro was different today is exactly 200 years since Napoleon died. So I thought I would just do an intro that mentioned his name, but that is Follow the Music by Hair Conjurer. Just so you know. Okay, so that doesn't have to do with anything about what we're learning, but I thought that was kind of interesting because it's exactly 200 years. Things like that don't happen that often. 100 years was 1921, so obviously no YouTube videos then. And then I guess maybe there will be one in 2121. I don't know. But that's not the point. So there's perfect radicals. So we've been learning about radicals. We already learned how to graph them, but now let's just see. We're going to have to do operations with them, on even if you don't like that. But you probably know your 2's and you might know your 3's. So basically, where do I have the thing on here? No, I don't. Oh, and that's this isn't exactly I don't know what I'm trying to say, but basically this is just a chart with all of the things that there are. So the index is the thing that is right here. We'll talk about this more, but the number that's right there. And if there is no number, it's a 2, basically. When there's no number, it's a 2. And if there was a 1, that would just mean just normal. So, like, for example, the first square root of 49 wouldn't be 7. It would be just 49, for example. But that's not really a thing. So we have our 2's, 3's, 4's, and 5's. And these are the indexes, or indices, I guess that's how you would say. And then base, basically this is the number that's being raised to a power. So for here, 1 is raised to the second power, then the third power, then the fourth. But obviously we know 1 raised to any power, even the millionth power, is still going to be 1. Now, I'm not saying you really need to memorize all these, because obviously you see there's a crazy one. You see 9 to the 5th is 59,049. But I'm just letting you see these numbers so that you can know when we are simplifying radicals in the next lessons, you need to know how to recognize things. We've already simplified radicals before, but if you have to the 5th root and you see a 243, for example, because that you see 3 to the 5th power is 243 right here, then if you see a 243, it would be helpful to know, oh yeah, I can take the 5th root of that. But basically, I mean, you don't necessarily have to know that, because even if you did a smaller one, you could simplify it further. But let me kind of just outline the ones that would be the most helpful to know. Well, might be kind of hard to do. Hang on. So you would pretty much, it's helpful to know all of these. And then I guess, not that it's not helpful to know some, but it's easier to remember ones that are maybe 3-digit. So you don't necessarily have to memorize that. It's just a suggestion. It would make things easier because you need to be able to know which things you can take roots of. And then, okay. So that's the ones basically. Especially the ones that are 1's, 2's, and 3's on these rows are the most helpful to know, because it just would be. You'll see what I'm talking about later on. And then I say down here, notice a pattern. If you see that the second root of 256 is 16, and then the fourth root of 256 is 4, that makes sense, doesn't it? Because if you take only the second root, you still have 16, and then you can take another second root, which really we call the square root. So if you take the square root of 256, you get 16, but you can take the square root of that. So you're taking the square root once and another time, which equals 4. And if you do it all at once by taking the fourth root of 256, you get 4. So whether you do it 2 times or 1 time for 4 times, like, it's hard to explain, but like, that's how they're connected. So it's not just random. You can take the square root of something, but so you can take the fourth root of it. But basically, I'm saying that the indexes, you can multiply them in that way, and you would get the same answer. Just like 2 times 2 is 4, you would get the same answer if you did 2 times 2, or if you just did 4. So that's what I'm trying to say. And then down here is 25. Well, we notice actually like that right here, you see that there is, we know that the square root of 25 is 5. And we know the square root of 4 is 2. So, do those equal each other? Well, we can type in the answer, and we would see that that's 625, and then that's also 625. So, yes, they do equal each other, but it makes sense because it's the same thing as the other one. When you take the square root of 625, and then you take the fourth root. You take the square root, you get 25. You take that, you get 5. But you can take another square root of that. So then we're doing 2 and 2. That makes 4. And that's what's there. So that's what I'm trying to say with that. But that'll actually be it for this video. So thanks for watching, and I'll see you on the next one.